the problem, so don't start writing it yet because there might be kind of a lot that we might have to squeeze in, or you might want to do some of it on a separate sheet so you can use it as good notes to help you. So we're going to take a look at this first problem. In this first problem, we are going to deal with, I need to look it up real quick. So you have a denominator where you just have a 1 in the numerator. Agree? So first thing you want to do this problem is you want to convert this problem to look like this. Okay, so I no longer have a fraction with it. And that's going to make it a simpler problem to work out when we, 6.3. It's going to make it a little bit simpler of a problem to work out when we start working on it, okay? All right, so this one is kind of called the power rule. You don't need to know the rules of the power rule or anything like that. But if I wanted to find the derivative of this, I'm going to do f prime at x. The first thing I do is I bring this down front. I'm going to subtract 1 from that, and then I have what's in parentheses, and that's going to now be raised to the negative 4th power. And then I take the derivative of the inside to get that. Okay? And things that we would want to do to clean this up is I don't want to deal with the negative exponent. The negative exponent means I'm going to turn this back into a fraction. The things that aren't raised to the negative exponent will be on the top. So I'm going to get negative 6x because negative 3 times 2x is negative 6x. And on bottom, I'm going to get this. And it no longer has, this is the derivative. No longer has a negative exponent. The derivative has been taken nicely. And it goes with that. Okay, so with that information known, will you try number 2 on your own? It's going to be done the exact same way. I moved the test. So try number 2. Give you a little time to take a look at it. All right, so it's already set up to do the derivative. So the derivative, I'm going to bring the exponent out front times what's inside the parentheses. Make sure you subtract 1 from this so you get negative 3. Then take the derivative inside, so I get 2x plus 4. And so my derivative is going to be, this needs to move down. So I could leave negative 2 up on top just like this. I keep the parentheses, that's fine. And this is going to move to the bottom, and it'll be to the 3rd power. So there's the derivative just as is. Questions? Feel all right about it? And I don't know if number 3 in particular is going to be seen on the test, but I want to show you how to do it regardless. So let's, hope I can move it over. Is it, everyone get that written down? Any questions? We're good? All right. For number 3, you don't want it to be under a radical to do a derivative. What we're going to do is, because there's a little 2 here, this is raised to the 1/2 power. So if I do the derivative of this, 1/2 comes down front. Then I'm going to subtract 1. And if I subtract 1, that's the same thing as 2 over 2 times this, as is. Subtract those, so that's going to give me negative 1/2 then. And then the derivative of the inside is going to be 2x plus 4. And then we can clean it up. So this needs to move down. This 2 is also going to be on the bottom with it because it's already a denominator. And then on top, you're just going to get 2x plus 4. And I guess on this one, you could reduce it, but I'm not going to worry about reducing it, being that the bottom 2 can go into both the top 2s, or the 2 and the 4 on the top. It's not net, I mean, in later math classes it would, so the top would become x plus 2, and then the bottom one wouldn't have the 2, but it'd have the whole thing in parentheses. We feeling okay? So kind of goofy on the derivatives, but you know, and again, my strongest advice to you is, again, if you have to take calculus for your degree, if you choose to go to college, it would be very much more advisable if you were to take it at the community college. It transfers over. It doesn't show up on your transcript that you, or like when you get your diploma, it doesn't say, hey, you're getting a Bachelor of Science from here, but you took this class at a community college. It doesn't say that. You just transfer it over. All right, we doing okay? All right. Number 4, change is something that's basically our product property. And so I just got to make sure I get it right, the lingo right in my head, because it always falls out. I'm sorry, it's something happened to me. When I took calculus in college, they actually allowed us to use a secondary resource, which was called Sham's Mathematical Handbook. And it didn't work out the problems, but it had all of the different things to do when you had these. And it became very useful because, again, memorization, you're knocking out about 1/3 of your population, which doesn't mean that that population's dumb. It's just their brain doesn't work that way. It's scientifically proven. Unfortunately, universities have not caught up with that. All right, so for this one, you have 2 different parts. So if I do this, I'm going to take the first part and just write it as is. And then I'm going to take the derivative of the second part. And there's a plus sign. And then I take the second part times the derivative of the first part, which is 5, which gets there. Hey, what's up? You here? You going back to what's your face? No? Staying here?
Yeah.
Cool.
Actually, yeah, I will.
Okay. There you go. Yep. And then that one's done. Some classes might require, I mean, if you can get to this point, you're great. If you were to FOIL it out, and then combine like terms, so those are like terms. X. Oops, I forgot that one now. That's going to give me minus 36 x, and then minus 6. So that, it cleans up a little bit nicer, though it might take a little bit more work to do it, but you can still do it. Problem number 5 goes to the quotient rule, and the quotient rule is very similar to the product rule of how we do it, except the plus sign that's in the middle turns into a minus sign, and then you put it over the denominator squared. So I'm going to I'll start the derivative up here. So I have the top, which is just q squared plus 3 times the derivative of the bottom minus the bottom times the derivative of the top. And it's all over the denominator squared. If we wanted to clean it up a little bit, multiply on the top, so I'm going to get 2q squared plus 6 minus 4q squared plus 2q. What I basically did here, if you didn't see it, is I'm incorporating this negative with this negative 2q, and that's what I'm distributing over. And then I forgot one part on there. Draw. This should have been squared. So then I can square the bottom. So that's going to give me, if I FOIL it out, 4q squared minus 2q, which is minus 4q, plus 1. And then you can clean it up a little bit. The top cleans up to negative 2q squared plus 2q plus 6 over 4q squared minus 4q plus 1. There was kind of a lot with that one, so let me know if you have any questions on how that worked out. It was just basically foiling and combining like terms is all I was doing. So algebra 1. So kind of the hiccup with any math classes, and it should not be a hindrance for you, and this is where when you start doing some investigating, and if you find yourself puzzled, if you're someplace, reach out to me and I'll help you find a place to take calculus that would allow you to take it to where you can do it. But one, if your arithmetic is really bad, which some students it is, that's for any number of reasons. Don't panic if your arithmetic's bad, because there are places that will allow you to use your calculator on stuff, which is great, and I truly support that. And then also, when you look to a place that doesn't require you to have things memorized, I mean, some places might say they'll let you use note card, which the hard thing with the note card is students will try to put any example problems down and then they'll run out of space versus the rules. But it's just part of the game of education. All right. I'm not going to worry about number 6. You will not see one on that. Number 6, you have to do the product rule. And then, or I guess you could FOIL out the top and then do the quotient rule. But number 6 could be a combination of the product rule and the quotient rule if you leave it as is. I'm not going to panic about doing one of those for right now. All right. So then we get to number 7, and they want us to find the slope of the tangent line to the function given, and they want to use it at x equals 2. Okay? So I think the important part of this one is let's find our point first. So I'm going to get 2 comma. Yo.
I moved the quiz till tomorrow.
All right. So, plug the 2 in first. So if I plug 2 in, that's going to give me the y value. So 2 times 2 times 2 is 8. So that would give me an 8 right there. And then 2 times 2 is 4. And then this is raised to the 4th power. And oh, goodness gracious, that's going to be a big old number. So 8 plus 4 is 12. 12 raised to the 4th power is, oh my goodness, 20,736. That's ridiculous. But it is what it is. Then we can go ahead and find the derivative. So we're going to bring the 4 down front, and then we'll subtract 1 from that, and then I'm going to get x to the 3rd plus 2x, and it'll be raised to the 3rd, and then do the derivative of the inside. Derivative of the inside is going to be 3x plus 2, and then we want to plug 2 into that. Let's go with blue. So I'm going to plug this 2 in here, and I would say definitely use a calculator for that. So 4 parentheses 2 raised to the 3rd plus 2 times 2 is 4, and then raise the whole thing to the 3rd, and then oops, and then 3 times 2 is 6. 6 plus 2 is 8. And so if I plug that 2 in, I'm going to wind up finding my slope is 55,296 over 1. So that's a very steep slope. That's very close to a vertical line. And then if I plug in a point slope, This becomes x1, this becomes y1, and the average slope, so you're going to get y minus 207.36 equals 55,296, x minus 2, and that's your answer. This is the equation of the line tangent at that particular point. And in my opinion, that is an absolutely ridiculous answer. You would not see one like that tomorrow. It's just, it's too big. Okay. I think we can get through one more problem. We'll skip the next one and we'll do the bottom one, then we'll call it good. And that should be helpful for you on the quiz. So we're going to skip this one. Does anyone need more time writing that down? And again, those answers are ridiculous. You're not going to see things like that. I mean, you might get things that are 100, but I'm not going to get you things that are in the tens of thousands for answers. Okay, so you know what, I'm going to skip that one too. I'm not going to give you one like that. Let's see, is there anything else here that these are next section or next test? So, bless you. So those are all the ones that would give you a pretty good start on the test, again, or the quiz. It's on Schoology. The weird thing is once it's on Schoology, it's not going to be like A, B, C, or D for the answer. You're going to have to type in. So you probably don't know how to make a thing an exponent on Schoology, and that's okay. So you could just have, like, if it was 2x squared, you could put like 2x caret 2, and that would show that, you know, there's an exponent there. So you won't be able to see the answers right away because I actually physically have to go in and go grade them each individually. But that will be, for the most part, what your quiz is tomorrow. I think it's, how many questions is it? Let's see, Schoology. Let's see, on Schoology. So if you went into our stuff, you could obviously see that this quiz is there. But this would have been 10 questions. So, but you guys get to work on it together. And then on Friday, would you like to learn about the best way to utilize a credit card? Because I bet you at some point you guys would want to have a credit card in your life. Agree? Cool. And I'll show you how to utilize it as a tool and not be a victim to how credit cards work. But that should be good, huh?